job is speed matching these three, and I'll videotape at least doing 2 of them, if not all 3 of them. In this particular instance, this is my test track, and all I really need is this outside loop is all I'm going to use on it. Here's a speedometer, the AccuTrack 2, for a DCC system. I'm using my ECOS ESU command station, and I'm using JMRI. And there you can see I've already got the roster up on JMRI. So the plan is going to be that I set my first local to the speed that I want, and then from there I'm going to set the second one, and then I'm going to go through a final session where I make sure those are very close. Now, something you need to know is this command station does not allow me to use JMRI for programming on the main. If I need to program through JMRI, I have to do it on a programming track. But I can program on the main through ESU by going to the Tools tab here. And just bear with me while I go through and find it. Here it is. You can see I can go to main programming track, put in the DCC address, the CV, and the value, and write that. So I'm able to do that this way. Now, from a programming track perspective, if we just move over here, you'll see that I have a small switch here. And for this length of track, all the way down past the blue rerailer to that switch, is an isolated piece of track with a double pole, double throw switch. In the medium position, there's no power at all. In the upwards position, I get regular track power, so it's the same as this piece of regular track here. And in the down position, it is a programming track. And all that is isolated through an isolated joiner, which is right there. It's hard to see, but there's cuts in the track there, and there's plastic joiners that are used on the bottom there. So that's how this whole thing is set up along there. Next up, I'm going to take the first local in question, which will be 9840 there, and I'm going to run it around and warm it up a little bit. The key thing, or one of the key things about doing DCC speed matching, is you got to make sure these locomotives are warmed up for, I don't know, I do it 5 minutes, 3 to 5 minutes first. Otherwise, as you're trying to set the speed changes over time as they get warm. So let's pull these other guys off, and we'll pull the programming track off. And I've already set that locomotive up to be 9840. You just saw me check to make sure it's on programming track. I will turn the track power on. I will go to JMRI here, and I will click on Identify. You can hear some clicking going on. Click. Now, if this is a brand new loco, I'd go on New Loco, I'd select the decoder, and I'd do all that. But you can see here where it has figured out it's 9840. Okay, and so I've clicked Programming Track here. I'm now going to click on the Program button. And you can see I've already entered all this information. And I'm just going to take a look under Basic Speed Control. I've already done some speed setting here. You can see start volts and max volts. So I'm going to reset this so that I can show you how I do this. This is now going to be set to 0. So I will write changes on sheets. Okay, so those changes have been written. And now you can probably hear this guy. I'll just do the whistle on it. And bell. Okay, this is the one I just sound converted. So what we're going to do is we're going to go back to our throttle here. And we'll get it up to 70, what says 74. And then what I have to do is make sure I change that turnout. Otherwise it'll derail the next time around. Now for warm-up purposes, I'm going to go to max on this. And what you'll see here, this is already timed out, so I have to turn it off. Wait a second, and there goes the car. Now this is set for kilometers an hour, and you'll see it's a bit fast, 338, a little more than I want it. On this particular one, I want to set my max speed to 224. The reason I want to do that is 28 speed steps at 8 kilometers per hour per speed step is 224 kilometers an hour. And if you look on my ESU, I've already got it set up for a maximum of 224 kilometers an hour. That's an ESU thing. So, what we want to do now is drop that 340 to that 224 number. To do that, we need to program CV5. And you can see here, I had programmed, this is max volts of CV5, I had programmed them to 0. In order to use this to program, I would have to go back to my programming track there, but I don't want to do that, I want to program on the main. So to program on the main, I'm going to go into my ECOS system here. I'm going to click on the Tools button. You saw me on Setup 2. And this is locomotive 9840, so we'll go here, and we'll go 9840, so we have 9840, and I want it to be CV5, and I'm going to write 100 to CV5, just to show you what the effect is on this car. So we'll click on right, and you see how much slower it's going now. And you can hear also how much slower it's going. Now that'll be less than the speed that I want, but it'll loop around, and we'll see that I'm at 181. So let's change this to 1, I can do it this way, 150, and write that. And now we're at 213, pretty close. Now instead of 150, let's bump this up to 155. It's already come around, so that's probably too much. I'm going to do it 153. Press right. And now let's see what the speed is. 216. Well, let's bump this up to 155. See what the speed is. 218, getting closer. I'm going to go to 160. 227, too much. So let's drop this to 158. 224, look at that. Let's go another round just to make sure. I want it to be within a few kilometers per hour, a little bit different, I don't mind. 224. Now what I need to know is I need to figure out what I need to adjust the start level if we go back here, you'll see that when I'm at this level, I should be at 8 kilometers, 16, etc. And so if I bring this around, and this is kind of a weird angle, I know, but right now we're set at 32 kilometers, and you can see it's barely running. If I drop it to 24, it's moving, but hardly at all. So I need to change the start. To change the start, I go to CV2, and I'm going to change this to 20. I'm just guessing. Okay, now we click OK. We go to the speedometer. I should be at 8. It's not even moving. I should be at 16. Well, it's now moving at 16. Let's see how fast that is. It's not 16 kilometers an hour, but it could be 8. This is where it gets a little bit tedious. 5.8. I will reverse that, and I've got my ECOS set up so I go boink. And now you can see that it's reverse going through there. And while it's going, I'm going to go to here, and I'm going to change this from 20 to 30. I'm going to write that. I'm going to change the direction of my loco. Remember, this is supposed to be 17 kilometers an hour. Wow, that's pretty good. I'm going to do reverse on that. Okay, so that's actually speed step 2. Let me go back to speed step 1 here. Now this is at, again, 30 for speed step 1. I should be at 8 kilometers an hour. Let's see what we're at. 6.9. Okay. When I'm doing this kind of stuff, the next thing I like to do is check the max speed again, because I'm pretty close on that minimum. So let's see where the maximum is. .219. So it's pretty darn close. Let's let it run a second lap, because sometimes it needs to warm up a little bit more. Okay, 222. Now, do you remember what I had set the min and max to? You know, I don't. So, what the hell? Am I going to start all over again? No. I'm going to back this guy into the programming track. And now I'm going to go over to ECOS. And I'm going to say, read full sheet. And you may not be able to hear the clicking, but it's clicking. 30 was the start volts. 0 at mid means a straight line, and 158 was the max volts. Now I'm going to go ahead and set up my speed table, which is the next thing here. So remember, 30 at the low end, 158 at the top. So I'm going to go here, and I want this guy at speed step 1 to be 30. So get it close and then use up and down arrows. And what did we say the top was? We said the top was 158. So I want this to be 158. Okay, 30, 158. Do a click mark there. Do a click mark there and say match ends. Now I have 30 here. I have 158 here and a nice straight line. I'm going to use this speed table, And now I'm going to write the full sheet. It will write each individual entry to the locomotive sitting over there. You can hear some clicking going on as it's writing. Okay, all written. Now let's send this guy out again. We're back at the ECOS, and I'm going to crank the throttle up full. And as soon as I see that's out, I'm going to change the switch setting. Then we're going to take a look at the speedometer and see that it's at 221. Now we're going to bring it around, and on the ECOS unit here, I'm going to drop it to 120. Sure, that's a good number. Let's see what it is. Look at that. So this guy is pretty much speed set up perfectly. And now that I've got... Okay, one thing I forgot is that if we're going to set up a consist, I do advanced consist. So from speed table here, if we go to consist, you'll see we have an advanced consist address. I'm going to do 98. Okay, all set up that way to respond to consist address. I'm going to do the write full sheet. And let me just resize this window. You can't quite see here. Down at the bottom it says OK. Now, did that work? Well, let's go here and apply full throttle. Look, nothing works. Why is that? Well, because it's now programmed to respond to 98. So I have to go back into my throttle here, and I'm going to manually create 224. I'm in 98 with 28 speed steps. And is that going to run? Let's twist the throttle, and the way it goes, we'll change the turnout again so we don't derail. Now if we come back to the speedometer, we're currently at max speed, 220. Yeah, close enough for me. Okay, so this one is now programmed. Okay, make sure they're both in the wrong direction again. Both going forwards, max speed. Okay? So if those are coupled together, you're not going to have an issue with the front pulling a little. Drop to mid-speed. Okay, mid-speed. Again, that gap is pretty consistent. What about at the lower end? Come through it. Well, it's not 62 now, but why don't we drop it way down like we're pulling out of a yard? See, like I'm happy at that. The front one might pull on the bit, but it'll keep a tight coupler. So next up, the final thing I do is turn that on, is I couple these. Okay, those are now coupled. So let's make sure we're going forwards and run them. And I listen for any extra sounds like wheel spin. So you may have to turn off the sound. There's full speed. I don't hear any grindy, any other kind of noises going on. When I look straight down at the coupler, there's a little bit of tension on it, that's fine. I look at the speedometer coming in, they're supposed to be at 224, they're at 220, close enough. And then I'll double check at other speeds as well. They should come through at 120 now. There's no grinding or anything going on. They're running just fine. .118 instead of 120. That's close enough. So overall, those are speed matched now, and I can do a third one if I want, but I have a different system that I'm going to set up later, but to use the ECOS ESU, so this guy, plus JMRI, plus a speedometer, you now seen how I do it.